In this video, we'll continue our discussion of section 7.1. This is over the definition of Laplace, so we'll start there. In this video, we're going to do one Laplace transform of sine, and then I'm going to give you the form of cosine and let you try it if you'd like to form it. Okay, so like the other problems, I'm going to go ahead and write the definition for Laplace. It's quite a bit of work here, so if you write big, you might want to spread it out. All right, so my Laplace definition is 0 to infinity of e to the negative st times the function dt. All right, so the one we're doing here will be the Laplace of sine 2t. So let's go ahead and change it to our limit. All right, changing there, 0 to n. And then we're going to have e to the negative st times sine 2t. You're not going to like this process. So we're going to have to use integration by parts 2 times through this process, your favorite. Unfortunately, we can't use tabular because neither one of those functions neither one of them vanish, meaning the derivative doesn't go to 0. So we wouldn't know where to stop. All right, so here's our u sub. I'm gonna have u. I don't know how you guys set it up. This is the way I learned it. I put a u, I put a v, and then I put du dv. And then I know I'm allowed to put one here and one here, and then that's where I start filling things in. So I know that let's go ahead in this case, I think it makes sense to do a sine 2t. That way, when we take the derivative, it's just going to introduce another positive. I didn't introduce a negative there. And then that means we have to put e to the negative st down here, dt, right? And the integral for that, which we've done in this section, you can also maybe think working backwards that the derivative of that would get me back. All right, so I know, I'm going to shrink that down just a bit because I want to fit things here. All right, so we get equals, the limit is still here. All right, I'm going to put a big bracket because we're going to need it. So remember, it's uv, so negative 1 over s, e to the negative st times sine 2t. And then I like to put this here so I don't forget. This has to be ran from 0 to n. And then the reason I did that is because now I do minus v du. So that's why it's a plus. And then I'm going to go ahead and pull out the constant, the 2, and then the s is considered a constant since our integrals with t. So it's 0 to n. And then what's left, if I multiply v du, then I'm going to get e to the negative st cosine 2t dt. Forgive me for the room there. We're just kind of limited. So I believe that's right. Let me double check my notes, make sure we're not going down a wrong road. Everything looks fine. Okay. So I'm going to go ahead and evaluate my first term there. So I'm going to go way over because I might need it. Not way over, just a bit. All right, so I'm going to go ahead and evaluate, plug in, and then plug in 0. 0 is going to 0 out because of the sign, thankfully. So we're going to get negative 1 over s e to the negative sn times sine of 2n. All right, and then we don't have a minus because we said that zeroed out. All right, plus, now I have 2 over s, and I'm just going to rewrite this thing. 0 to n e to the negative st cosine of 2t dt. All right, and there would be a bracket. I'm off the screen, so I'm going to leave it there. Okay, so I have that. We still don't want to take our limit. Actually, we should. I know we still have more work to do here, right? We still have to get through that. But if we were to take the limit of this thing, we're not going to touch it anymore because we're going to have to work on the integral. But if I were to go ahead and take that limit, well, this goes back and forth between negative 1 and 1. But this e to the negative st is going to make the whole thing go to 0. So I might as well get rid of that, move it out of the way, because I know that I have to write quite a bit. Okay, so I'm going to just start there. We know that whole term is gone. And I guess let's make it look pretty. 2 over s integral 0 to n e to the negative st cosine 2t dt. All right, again, this looks very familiar, right? This looks just like what we started with almost. We're gonna have to do another u sub, unfortunately. So we got u du v dv. We're going to set it up the same way. I'm going to let the cosine be here, even though I'm going to get a negative. That's okay. I get, I'm going to have to spread this out just a bit. Actually, let me move this down. I think I need more room. All right, I know I get that, so that means I'm going to get a negative 2 sine 2t. If I used cosine 2t, I got to use e to the negative st dt here, which means that is negative 1 over s e to the negative st. Okay, so I'm going to write that. We have our integration by parts. I'm going to have to write pretty small here to get it filled in. I'm going to leave the 2 over s outside the very front, so I don't have to mess with it for a moment. Remember, it's uv, so I'm going to have a minus 1 over s e to the negative st cosine 2t. That was uv. And then it's going to be minus v du. Okay, so the minus is still there because those negatives are going to cancel. I get a 2 over s here. Integral from 0 to n, and then I got e to the negative st times sine 2t dt into our brackets. Okay, I want to make sure I'm good with my notes because there's a whole lot going on here, and I really don't want to mess it up mid-problem. Okay, I think everything looks all right. I'm going to go ahead and distribute that 2 over s. We can go ahead also, oh, we need to make sure we go from 0 to n here. Need to write that in there. So let's go ahead and rewrite. I'm going to spread things out. The limit as n approaches infinity, and I'm going to go ahead and distribute. I get negative 2 over s squared. And then I'm going to get e to the negative sn. So we'll do a parentheses here. And then I got a minus, and that means that if I plug in 0, cosine of 0 is 1, so that's still good. E of 0 is 1, and I'm minusing that, so I'm going to add a 1 over s. All right, and then minus, we get 4 over s squared of the integral, sorry, of e to the negative st sine 2t dt. All right, we can do some of our limit here. So if you'll take a look, this thing definitely that term is going to 0 because of the net e to the negative sn. This is going to leave us with the limit as n goes to infinity of negative 4. And let's go ahead, actually, let's pull that negative 4 over that 1 over s. We'll pull the 1 over s out. Now we got to be careful here. Actually, I think I'm going to rewrite. Let's go ahead and do that. Hold on, I think there might be a mistake somewhere here in my work. I'm double checking. Careful, here it is. I still get a 2 there. And it's still s squared. Be real careful. We almost messed up all that. So double check that. That was plugging in, but when I did the 0 plugged in, like minus, I ignored that. All right, so we are good. So we're gonna get, if I write this next line, I'm gonna get 2 over s squared out of that after I take the limit, because there's no n. And then I'm gonna get minus 4 over s squared. And then if I take the limit, like if I were to put this thing here with this thing here, that's like what I have left. Like everything else I just kind of pulled out. But that thing is actually my Laplace of what we were trying to find, right? This thing is the same thing as blue up there. Not the whole thing, sorry. This thing. That is the exact same as what we just wrote up in blue up there. So I'm going to rewrite this. This is how we're going to get to our answer. We took the Laplace of sine 2t, and we got the answer 2 over s squared minus 4 over s squared, then our Laplace that we were looking for. We can solve this equation. We have two unknowns there. So really, if I add that 4 over s squared, I'm going to get 1 plus 4 over s squared times the Laplace of sine 2t, right? That's adding this whole term over, and then I factored out the Laplace. This is equal to, let me fix that brace, it didn't look good. equal to, not much better, but we'll take it, 2 over s squared. So what that means is that our Laplace, okay, is going to be the Laplace of sine 2t. And we'll have to do some probably simplification here. I got 2 over s squared. And then for a moment, let's go up here and I'm going to work on something real quick and then come back. It'd be really much easier if I put this as one fraction. This is s squared plus 4 over s squared. Go ahead and check that. Make sure you're good with that. Um, that's what's actually over here on the left side. So if I divide by it, I get s squared over s squared plus 4. So we actually have our Laplace now. So I'm going to write that here, Laplace of sine. And then let's go ahead. If you take a look, what's going to happen, those s squareds are canceling. And then we're going to write, I'm going to go ahead. We have our answer. You can see it there. Here's our general answer. I'm not going to put a 2, but I'm going to put a k. So if we were to use 2 over there with what we got, we had a k on top, and then we had s squared plus k squared. That is our sine. All right, so sine of kt, the Laplace transform is k over s squared plus k squared. Now I'm going to go ahead and give you this, and I challenge you to derive it yourself. The Laplace of cosine kt is equal to, it's going to be s on top now, no variable. Or that's a parameter, not the that's our variable, not the parameter, my bad, over s squared plus k squared. So the only difference is either the k is on top or the s is on top, and you just got to find a way to keep that straight. Most of these problems, I will be giving you a table. I'll make all that clear right before your final exam. All right, so that's it. We're going to do a couple more problems, combining rules, making things a little faster. And then we're going to take a look at what if we take the Laplace of a piecewise function.